Hey everyone, today I'll be doing the term 2 week 1 mechanics quiz. So, first question, which of the following are not field forces? Now, what is a field force? A field force is the same thing, that's an arrow, the same thing as action at a distance. Okay, action at a distance. It's the exact same thing, it's just another word for it. So, not a field force, what does that mean? This just means contact force. Okay, now, which ones in this list are contact forces? The normal reaction and the tension, right? Because weight, as you know, is action at a distance or field force. Same thing for electric force and same thing for magnetic force. Okay, moving on to question 2. Okay, let me just move question 2 to the notes so I can have more space to solve it. Okay, so this is our question. Here, this is how the setup is. Now, they told us a wooden block of weight 6 newtons, so the weight is 6 newtons. So let's just label that here. I'm gonna write 6 newtons under it. Okay, is pulled up along an inclined slope of inclination 80 degrees by a force F of magnitude 15 newtons. My God, 15 newtons. Okay, now, and opposed by a frictional force F of magnitude 2 newtons. So let's write that down, 2 newtons. Okay. As illustrated in the free body diagram. Now the question, I wrote it here, find the net force along the incline. Along the incline literally just means this x. Right, so I'm not worried about y. Even though you can tell from now y is gonna be 0. I'll explain why later. But let's just focus on x now. So, first of all, as always, when you're dealing with inclined planes and they give you the weight like this, you have to split it up into its components. So this is wy here. Right? And we have, wait, let me just write the arrow. And we have wx here along the incline. Okay, now, how do you find them? Remember, the forces switch up for weight. Now, for wx, instead of it being w cosine theta or cosine alpha, whatever, it's actually going to be w sine alpha. Obviously, when alpha is given to be with the horizontal, which 99% of the time is. So, now, wx is equal to, w is 6 sine 30 degrees, which obviously you don't even need to like have a calculator with you. This is just 3 newtons, because sine 30 is 0.5. Now, wy is w cosine theta, right? Now, wy in this case is going to be 6 cosine 30, which is cosine 30 is radical 3 over 2, so 3 radical 3 newtons. Let me just make sure. 6 cosine 30. Yes, 3 radical 3 newtons. Okay. Now, we don't really need this. But I just did it, this part here we don't need. I just did it to show you something. Now, here, you see how the normal and the y component of the weight are the only two forces on our y-axis. What does that mean? That means for the normal is going to be equal to the y component of the weight, right? They're going to be the same thing. This is by Newton's laws. So, when we're going to find the net force along y, even though we don't need it in the question is not asking for it, but it wouldn't make a difference. Say you mixed up in the exam. In this case, it wouldn't matter. Why? Because Fy net is just going to be the normal is directed upwards, so we're going to do upwards minus downwards, and minus wy. Now, n is equal to wy. So what is this? This is genuinely just wy minus wy, which is what? 0. So Fy net is 0. So the net force along y will not make a difference to you. So even if you mix up in the exam, in this case, since we only have two forces, the normal and the y component of the weight, don't worry about it. Nothing changes. So this part wasn't necessary, but I just wanted to add this a quick note. Now, let's find fx net. So, fx net. Now, let's take this direction to be positive, right? So we only have f as positive. 15 minus, we found wx. Wx is what? Wx is 3. 15 minus 3. And don't forget the friction force of 2 newtons. So this is 15 minus 3 minus 2, which is 10 newtons. And this is the net force along the incline. And that's your answer. Okay, let's just see. 10 newtons. Yes, it's correct. Let's move on. Okay, let me move this all of this over to the notes. Give me 1 second. Okay, this is our figure. Now, three forces act on a body as shown below. Find sigma Fy. This literally just means find Fy net. Because remember, you can write sigma to denote net. Doesn't matter, they're the same thing. I just did it like this to, make it easier for myself. Okay. Now, so let's label our forces. Let's say this one is F1. Doesn't really matter which one we label F1, F2. This is F2, and this is F3. Okay, now Fy net, I'm not gonna bother resolving into the X components. I'm just gonna focus on the Y component. Okay, let's start with F2 since it's on the positive X axis, in the positive quadrant. So, F2X is equal to 3.2. This is gonna be cosine 45. So, 3.2 cosine 45 is 8 radical 2 over 5. Now, here, in this case, we are lucky. 45 degrees doesn't matter sine or cosine. You will get the same answer anyway. Try it. 3.2 sine 45 will give you 8 radical 2 over 5. Same exact thing. So, in this case, we're not gonna complain too much. But if you ever forgot the rules, remember, if you have a force like this, okay, and you have, what am I saying? It makes an angle here, theta, with the horizontal, right? This can be split up like this. Fx is F cosine theta, Fy is F sine theta. All right, now here our angles with the horizontal, that's fine. We want the y. Why did I do x? I just realized I did x for no reason. I said I wouldn't bother with it. Okay, so I'm gonna change that to y because I mixed up my directions. The answer doesn't change. It's fine. It's still the same exact thing. Okay, now let's find F1y. So here's the thing about this one. This is 72 degrees with the negative x-axis. We need it to be with the positive x-axis. So what are we gonna do? This makes a straight line, right? So 180 minus 72, 108. So this is actually 108 degrees. This is the angle we're concerned with. Our angle always has to be with the positive x-axis, never negative. So what did I do? It doesn't really matter. Okay, so what's this force? 4.3. 4.3 cosine 108 degrees gives me 1 second. What did I do? Okay, I just realized I made the same exact mistake I did the last time. This is sine, not cosine. And this is also sine. Remember, y is sine. So 4.3 sine 108. 4.089. Do we just round to 4.09? Let's round to 4.09. Doesn't make it that big of a difference. Okay. Now, F3, as you'll notice here, is directed exactly along the y-axis. I don't need to split it up into its components because it makes 90 degrees. It makes 90 degrees with the positive x-axis. So I don't really care that much, right? Or it actually, well, technically it makes 270. It's fine, it's fine. I'm not going to concern myself with this. So since it's exactly along the y-axis, I don't need to do any component splitting, cosine, sine, whatever. So I can just write F3y is 2.9 newtons. Straight away. Now, if we were to add direction, this would actually be negative 2.9 newtons. Why? Because we defined upwards this as positive. Right? So this is acting downwards. So what is this? This is negative. This is negative 2.9. So what are we going to do now? We're going to find sigma Fy. So 8 radical 2 over 5 plus 4.09 minus 2.9 gives me, so 8 radical 2 over 5 plus 4.09 minus 2.9 3.45 newtons, which we can round to 3.5 newtons. Okay, let's check if this is the answer. 3.5 newtons, perfect. Moving on, question 4. Okay, so I'll also move this one to the spaces because this one, the solution is easy. Doesn't take that much space, but just in case. Okay, so this is the question, and I also drew the free body diagram because it's too long to draw and I want to save time. So the figure below shows a homogeneous block of mass m placed on 4 identically spaced springs of constant k each. The block is in equilibrium. The expression for the compression of each spring is. So this is the FBD, right? You have these 4 springs acting on upwards, obviously, right? Because they're giving this force. Now, in actuality, they are under this block, but that doesn't matter. They are exerting an upwards force, each of them, right? Because they're obviously not exerting downwards. How are they keeping it holding? How are they keeping the block upwards, like holding above the ground? Doesn't matter if they're exerting downwards. Doesn't make sense. So at the same time as all of this, you obviously have the weight of the block, right? So you have mg and then fs. Fs is the force of the spring. So you know from Hooke's law, F or Fs, the force of the spring, is what? Kx. Now k is a constant, I don't really care about it. This is what I care about. X is the compression. Alright, so you can write 4kx because we have 4 of this. There again, the springs are identical, so Fs is the same across all of them, right? So you can write 4Fs minus mg equals 0. Sorry, you can write this. I don't know where I was, but I will just continue from here. You can rewrite this as what? 4kx, right? Because 4Fs is the same thing as 4kx because Fs is kx minus mg equals 0. Why? Because by Newton's law, when it's in equilibrium, you can write sigma. Since all of this is acting along the y-axis, right? You can see all of this is along y. You can write sigma Fy is equal to 0, right? It's the same thing as Fy net, doesn't really matter your notation. But this is the core concept. Sigma F is equal to 0 in equilibrium. Okay? Now, this is exactly what we're applying here. So 4kx minus mg is equal to 0. Let's rearrange. So 4kx equals to mg. Divide by 4k on both sides. X is equal to mg over 4k. This should be the answer. I'm actually not sure. I didn't look at the answer solutions, but I just solved the quiz once. So I'm pretty sure this is the answer. Let me just check. Give me a second. So Chrome. Yes, mg over 4k. We have mg over 4k. Good to know. All right, next question. Question 5. All right, the form of energy liberated by friction is thermal. Obviously, think of it as when you're pumping the brakes or you're rubbing your hand against the wall very quickly. You'll feel heat in your hands, you'll feel it hot and it'll start to burn. When someone rubs their hand along your head, you remember it burns, like rubs their knuckle along your head. Your head will start to hurt, it'll start to burn. Why? Because that's the thermal energy. So this is the form. Obviously, elastic doesn't make sense. Nuclear, like, am I detonating a nuclear bomb when I press the brakes? Doesn't make sense. Gravitational potential, it's kind of the opposite, actually. And mechanical, some people would think that, but it's actually a trick question because this has nothing to do with fiction. The form of energy liberated by it, at least. All right, so question 6. Okay, a block of weight 4.7 newtons is placed on a rough inclined plane of inclination 37 degrees. The block is held at rest by a massless string under a tension of 1.3 newtons as shown in the figure below. What is the magnitude of the normal reaction of the plane? Okay, so this here is the question, right? Now, what did I say in the other question? When you only have 2 forces here, if you split it up into 2 components, I'm not going to resolve W into WX. I only care about WY. Why? Because they want the magnitude of the normal reaction, right? This is the normal reaction along Y, right? So I only care about Y. Now, WY is W cosine 37 degrees. So 4.7 cosine 37 degrees, because they gave me the weights 4.7. 4.7 cosine 37 degrees. 3.75 newtons. Okay, remember what I said, when we have only 2 forces acting on the y-axis, those being the normal and the y component of the weight, you can write by Newton's law. Remember, obviously the block's not flying in the sky, so it's actually holding to the inclined plane, right? So sigma Fy is equal to 0, right? Because it's not moving up or down. It's moving to the right in this case because of the tension. So don't forget your vector arrows. You can say the normal minus Wy is equal to 0. What does that mean? N is equal to Wy. So using this, now we can find the magnitude of the normal reaction. Now, you know that Wy is what we found it, 3.75. So this is the same thing as the normal reaction. This is your answer, 3.75 newtons. Let's check. 3.75 rounded to 3.8. Yeah, that's correct. They just rounded to 3.8. Okay, question 7. Which of the following is the non-inertial frame of reference? Inertia, basically, you know what inertia is. I can't really explain inertia to you. It's annoying to explain. So a stationary car is an inertial frame of reference. This is correct. Well, it's wrong in this context, but it is an inertial frame of reference. Uniform rectilinear motion, whenever you see resting, uniform, stationary, stopped, whatever, it is inertial. Or constant velocity, whatever. You see constant or stationary or not moving, it's inertial. Or yeah, it is inertial, not non-inertial. Ignore this. It's inertial. Okay, so this is uniform rectilinear motion. What does that mean? V is constant, right? V equals K. So this is not non-inertial, this is inertial. A book resting on a table, as I said, it has like stationary or moving at a constant velocity. This is stationary, so this is inertial. The floor of a playground is not moving anywhere, last I checked. So this is non-inertial, or sorry, this is inertial. This is non-inertial, however. A rotating wheel. It is moving, but not only that, it is moving like this. And it's obviously gonna rotate at a different rate every time. So this is a non-inertial frame of reference. Point is, the key context here is whenever you see stationary, rectilinear, uniform, no, don't discount uniform. Rectilinear fair, uniform rectilinear motion, this keyword here, stationary, constant velocity, acceleration equals to 0, those kinds of words, you count that as inertial. But here they want non-inertial, so we're gonna write a rotating wheel. Sorry if that was a bit confusing, but I'm assuming you got the key takeaway from it. Question 8. A block is sliding down a frictionless inclined plane as shown in the figure below. Which of the following is the free body diagram of the block? Okay, so here you only have two forces, right? They didn't tell you it's being pushed. They told you it's sliding like this by itself. Now, what is this? This is due to the x component of the weight, right? But we're not going to split the weight into its components in the free body diagram normally. So we're just going to put the weight itself. Obviously, this is left to the person who's solving the problem to split it into its components. So we're just going to write it as weight, right? W. And the normal reaction force, or R, doesn't matter, because this isn't exactly normal, but you can count it, it's fine. So this should be our free body diagram. It should look something like this. So you have this box here, you have the weight always going vertically down, and then you have the reaction perpendicular to the surface. So this is your diagram right here, which matches the second one, right? Now, moving on to question 9. A car rounds an unbacked curve of radius 250 meters at a speed of 20 meters per second. What's the minimum coefficient of friction required to prevent sliding? Now, there's a formula here, right? When it banks a curve like this, or when it rounds, basically, it goes like this, right? This is something like the road. Now, there is a formula for this. It's centripetal force, okay? Centripetal force is mv squared over R. Okay, now minimum coefficient of friction required to prevent sliding. That means the coefficient of friction, which we call mu, right? This is mu. Mu has to be greater than this, right? So what do we do here? We have to find friction. We have to say that obviously friction, and to begin with, if the coefficient of friction has to be bigger than this, friction has to be bigger than this whole thing to prevent sliding, right? Now friction is what? Mu R. Or mu n, doesn't matter. Now, let's draw the free body diagram of this. The car is tilted like this. Well, this is a way too sharp of a tilt, but you see it, like the car is rounding this thing. So, you have your wy like this. I'm gonna split it straight away. And normal. I don't care about anything else. I need normal and wy. You see, we only have two forces. What does that mean? The normal is equal to wy. However, this isn't an inclined plane. Wy is the same thing as w, right? So I don't even know why I included wy. So n is equal to mg, right? N is equal to mg. So what do I say now? I will say mu mg is greater than or equal to mv squared over r. Alright, now mu can be rewritten, or we can divide mg, sorry, on both sides. You're gonna cancel m with m, so you're gonna get v squared over rg. Right, now we have v squared, or we have v, we can square it. We have r, we have g. So mu is greater than or equal to 20 squared over r is 250. G is, let's take it as 10. They didn't tell you take it as 10, doesn't really matter. So this is the same thing as mu greater than or equal to 20 squared is 400, 250 times 10 is 2500, 0.16. Which is actually our answer here. Now, I don't think this is coming. We never took this. We didn't take the centripetal force formula. It's just a formula I just know from last time, because this question or a similar one came in the quiz and I just remember it. But this is just algebra. If you know this is a fundamental formula for this question. If you know it and you see the minimum coefficient of friction, so you realize that mu has to be bigger than this, right? If you realize those two, it really becomes easy. So you shouldn't worry about this. So I don't think it'll come, but just in case, know how to solve it. Obviously, just recall that friction has to be greater than this to obviously prevent it from sliding, because that's what friction does. Anyway, yeah, moving on. Question 10. I don't want to look up the definition of 4. Okay. So the length, three springs of the same natural length L are deformed by three forces F1, F2, F3. The final length of the three springs is the same. The stiffness of each spring is shown in the table below, which is following correctly compares the magnitudes of the forces. Okay, so for this one, we're gonna use the Hooke's law formula. Where am I? What? We're gonna use Hooke's law. So which is F equals Kx, if you remember from the other question with this compression. This is the compression here, or the extension, doesn't matter. If it's being extended downwards, like the spring is being pushed in, it's called compression. If it's getting elongated, we call it extension. Now, here, so naturally, you can say that K or F, doesn't matter, F is directly proportional to K, right? So that means as K increases, F will increase, right? Now, here, 1.5K. F2 is going to be my biggest. Why? Because K is the largest here, right? So F2, or spring 2, doesn't matter. Spring 2 has force F2. This is the biggest one. This is followed by this one, F1. And then F3 is the least, or smallest, right? Because this is essentially just proportionality and Hooke's law, right? Because if K increases, F will increase, right? As we said here in these two. Now, K is increasing here the most in 2, so F is increasing the most, meaning F2 is the biggest, followed by F1 and then F3. So F3, F1, F2, the last option is the correct answer. Question 11. Okay, this is really easy. Let me just move it into the notes app. Give me a second. Okay, so this is this question in notes, just so I can have more space. Now, the displacement of the particle between t equals 0 and t equals 3 is something meters. This is the equation. I'm not going to bother reading the rest of the question. This is a very easy question. So, the displacement, right, is delta x. Where am I? Why did I go up? So, the displacement is delta x, right? Which is what? x2 minus x1. So, let's label our x2 and x1. Obviously, the x1 is going to be at t equals 0, right? So, that logically means x2 is going to be at t equals 3. So let's substitute t equals 0 in this equation here, right? x1 is equal to 4 times 0 squared plus 3 times 0 minus 5, right? This is just minus 5 meters. Now, x2 is 4 times, remember, time is 3. So 4 times 3 squared plus 3 times 3 minus 5 equals to Off the top of my head, this is 40, but let me just make sure. 4 times 9 plus 9 minus 5, 40. Yes. Now, x2 minus x1. So 40 minus negative 5 gives me 45 meters as my displacement. And this is my answer, 45 meters. Now, the average velocity of the particle between t equals 0 and t equals 3. So remember, the formula for average velocity is what? Delta x over delta t, right? We have delta x, 45, right? 45. Delta t is what? 3 minus 0, 3 seconds. So 45 over 3 is 15 meters per second. This is my answer, 15. Okay, see, the velocity at the particle, the velocity of the particle at t equals 2 seconds is, now, to find instantaneous velocity, not average, you do the derivative of the displacement, right? Remember the three ones, so you have x of t. To get to v of t, you would want to derive, so you're gonna do derivative d by dx, or d by dt, in this case, v by t, and then to get to acceleration, you'll need this for the next part, you derive again d by dt, you'll get a of t. Now, to get to velocity from acceleration, you integrate, sorry, that's on integral, you integrate, and same thing with velocity to displacement. Right, same process, but here we're not worried about going the other way, we're just going this one way here. So to get to velocity, we're deriving or differentiating x of t. So this is equal to, let's derive 8t, because 4t squared, remember our power rule, you take it down, multiply it, and subtract 1 from the power. So 2 times 4, 8, 2 minus 1, 1, so t to the power of 1. Now 3t to the power of 1, 3 times 1, 3, 1 minus 1, 0. So this is our velocity formula. Now, we're going to substitute t equals 2. So this is just going to be 8 times 2 plus 3. 8 times 2 is 16, plus 3, 19. 19 meters per second. Okay, D. They're asking for the acceleration at any time. Why are they saying any time? Remember, to find the acceleration, you differentiate the velocity. So a of t is equal to v prime of t. So derive this. Derive 8t plus 3. 8t plus 3, this is just a constant 8. So at any instant in time, at any time, you will have your acceleration to be 8 meters per second squared. At any time. Because why? It's constant. It's just 8. It's always 8. So let's just make sure our answers is 45, 15, 19, and 8. 45, 15, 19, and 8. Perfect. Okay, let's go. Question 12. Okay, I'll move this to the notes up. Give me a second. Okay, so two particles A and B of masses 2 and 3 kg respectively are connected by a light inextensible string that passes over a slight smooth pulley, particle A or pulley B. A particle A rests on a smooth horizontal surface and B rests on an inclined smooth plane with the string taut and perpendicular to the line of intersection of the table and the plane. The system is released and accelerates at accelerates at 4.5 meters per second squared. Take G as 1.8 meters per second squared. Choose the correct answer to complete the sentences below. Now, the tension of the string. How do you find the tension? So let's first draw what we have. Let's first resolve our components and our forces and whatever we have. So I'm going to start with A because it's the simplest. We have the gravity, the weight, mg. I'm just going to express it directly as mg. And what do we have up here? We have the normal. Done. This is for A. No, we're not done. We have the tension. So tension. Right? Now, B, where it gets a little bit more complicated, you have the weight going perpendicularly downwards. Let's just resolve it into its components. From now, you have here, that's a bit too steep. You have here Wy, right? You have the reaction force. You have the tension. And you have the X component of the weight. All right, perfect. So this is our drawing, right? It's very easy so far. There's nothing new. Now, to find the tension, will I take this case where there's components and there's 15 different forces to work with, or will I take this case where there's literally one force on the x-axis and that's just the tension, right? So what will I take? I'll obviously take this case where there's one thing on the x-axis, so it's much easier to say. Why? Because I'm just gonna write sigma of x. They told me it's accelerating at 4.5 meters per second squared, so I'm gonna write sigma f equals ma, right? So let me just draw my vector arrows. Here I'm gonna write sigma of x. X is the only thing on x for, what's this block? This is block A. This is block A. The only thing on x is the tension. So T is equal to M. What's M of A? A is 2 kilograms. 2 times 4.5. Because I remember acceleration is 4.5 meters per second squared. This is just 9. 9 newtons. So this is my answer. 9 newtons. For tension. Done. I figured out part A in 2 lines. Okay, part B. The angle that the inclined plane. Okay, this is where things get a little bit complicated. Because now, here, you need to know the direction of motion. You need to know, is it going this way? Is it going this way? Is it going... Where is it going? This entire system, where is it going? Now, you can compare two things. Obviously, this will be the deciding factor, right? Because this block is getting pulled this way, right? This block is going this way, whether you like it or not. There is no force that's saying you're going this way. No, there is nothing here. There's only this force. So this is figured out. As for this one, block B, you have to compare the tension and the weight. Now, logically speaking, by intuition, if this is going like this block A is going like this, then logically the block B should go like this, right? It's following the same direction. But sometimes you can, like physics does weird things, so we can confirm this mathematically by comparing Wx and by comparing it with T. Now, Wx is 30. Right? Wait, what 30? Yeah, mg sine theta. So 30 sine theta. Now, the only case where like this could possibly be bigger, or tension can possibly be bigger than I don't know, the weight, is if theta was like, I don't know, less than 15 degrees maybe? Let me just check. Yeah, if it was less than 15 degrees. And even then, that wouldn't really make sense. Because the forces wouldn't work out the way they're working out right now. Plus logically, خلاص, يعني you said this is going like this, so this has to follow like this. Right? Otherwise, it wouldn't make sense. How on earth are you going like this and like that? Doesn't make sense. So this is the best choice. We're going to say Wx is the positive motion. Right, we're gonna say this direction is the positive motion. So, sigma fx is equal to what? Ma. Right? It's gonna be Wx minus T is equal to, M of this was 3, right? Yes, 3A, 3 times 4.5. Which is what? 13.5, right? 3 times 4.5, 27 over 2, 13.5, yes, 13.5. So, tension is 9, right? So Wx is equal to 13.5 plus 9. Remember, tension is 9. I just took it over to the other side. Add it to 9. You get 22.5 newtons. Now, what do you do now? Remember, Wx is what? W sine theta. Now, how much is W? W is equal to mg. M is 3. G is 9.8. 3 times 9.8. It's how much? 3 times 9.8, 29.4 newtons. Right? This is W equals mg. So, we're gonna write now Wx is equal to 29.4 sine theta. What is this equal to? This is equal to 22.5, sorry. Now, so sine theta is equal to 22.5 over 29.4. So theta is going to be arc sine, or the inverse sine of this. Just do it on your calculator straight away. You don't need to show you working. Sine inverse of 22.5 over 29.4, 49.93 degrees. I'm assuming they will round it to 50 degrees because it's only logical for them to do that. So this is our answer. Okay, so our answers are 9 and 50 degrees. Let's confirm. 9 and 50 degrees. Perfect. Question 13. Okay, let me just copy and paste this question to the notes. Okay, so this is the question in the notes. Let me just go back to the first part for the free body diagram. So where did I go? Hello, can I go to the answer? Where am I? This is not the correct question. Okay, I'm back. So this is the question. Now, a block of wood is sliding down a rough, oh my god. A block of wood is sliding down uniformly along the triangular prism of sides 3, 4, 5. The sides of the prism are rough. So neglect air drag and use G as 10 meters per second squared. Okay, this is good. They're simplifying our calculation. So which of the following is the free body diagram of the block of wood? Okay. So your block of wood has like 3 forces on it, right? It has the weight. Obviously, the weight acts vertically downwards. I don't know why I did like that. The weight acts vertically downwards. This is W. And then you have the reaction force or the normal reaction. You can draw it as R or N, doesn't matter. And then you have friction, right? Because it's rough. It says it here. It's rough. So this is the free body diagram. That's it. There's no more forces. Because you'd have to split up the weight into components. Yeah, that's it. These are the forces. You have the reaction force, the weight, and the friction. So the normal reaction, they represented with N, the weight, mg, and F. Done. Okay. Now for part B, they want us to find the coefficient of friction. Find mu. Okay. This is the free body diagram. Now you have to recall that a 3, 4, 5 triangle is what? It's a Pythagorean triple. So what does that mean? It's a right triangle. Remember, 3, 4, 5, and its multiples, the multiples of them, like 8, 6, 10. Those are those are right triangles. So find mu. Now how do we find mu? You don't have any numbers. You don't have any numbers to work with. So to find mu, it's actually not that hard, but you need to focus a bit. Now, how do we start? I want to first say F is equal to mu R, right? Or mu N in this case, because they chose to represent the normal reaction with N. Okay, now I can say sigma Fx is equal to 0. Now, why am I saying 0? Remember, sliding down uniformly. This is a very important keyword. What does that mean? Sliding uniformly. What does this mean? This means that A is 0, right? It's not accelerating. Remember, this is inertial. Like remember last time I said when it's uniform or those words like stationary, those words like nothing, no change. Essentially, it means no change. Acceleration is 0. And that means inertial. So, inertial frame of reference for that question's context. Don't take it into this. Now, remember, Fx is what? MA. But A is 0. So what does that mean? 0. Sigma Fx is 0. Done. Now, what are our only 2 forces on X? The friction and the Wx. Now, it's sliding down. So obviously Wx is greater. Wx is like the positive side, we're going to say. So Wx minus F equals to 0. So F is equal to Wx. Now, what is Wx? We have mg, and we don't have mg. 10m sine 37 degrees. Also remember the angles for this triangle is 90, 37, and 53 degrees is here. This side here is 53 degrees. Okay, now you don't need m. You don't need m, not yet. Actually, you will never need m for this question. There's a reason they didn't give it to you, because that means it'll cancel out. Now, sigma Fy is also equal to 0. Remember, the block's not going up or down or flying anywhere. What are only 2 forces? We have the normal or the reaction and Wy. So R or N, because they chose to represent it with N minus Wy is equal to 0. Now what does that mean? N is equal to Wy, which is equal to 10m cosine 37 degrees. Now, we're gonna go all the way back to our first thing we wrote. The first thing we wrote. what is it? F equals mu n, right? So F equals mu n. F was what? 10m sine 37 degrees. Okay, mu n is what? 10m cosine 37 degrees. So divide to find mu. 10m sine 37 over 10m cosine 37. So 10m and 10m will cancel out. This leaves what? Sine 37 over cosine 37. Which, if you think about it, remember, sine over cosine, this is tangent. Tan 37 degrees. Right, now just do on your calculator. Tan 37 degrees. Done. 0.75. This is your answer. 0.75. Okay, now for part B. I already drew the free body diagram, and the question literally just told you the block is now placed on the 3-meter side. Find the acceleration. Okay, so I drew the free body diagram for us. This is what's happening now. Okay, the 3-meter side is this, right? And the angle is 53 degrees. Remember, because if I said up here, the 4-meter side is 37 degrees. Remember, the 4-meter side in a 3-4-5 triangle will have the angle of 37 degrees. The other one will have 53 degrees. Do 90 minus 37. You'll get it. So now what do? You will simply do the same exact process you did the first time, but now you're including, instead of 0, it's MA. So first of all, sigma of x equals to MA. Okay, now we don't have M, but we hope it'll cancel out soon. So what do we do now? Literally, again, for the second time, this is the exact same process. So Wx minus F is equal to MA. So Wx is what? Wx is, what was it? Wx is 10m sine 53 now, right? Again, the only thing we changed was the angle. Literally, the only thing we changed was the angle, and that caused an acceleration change. And the distance, obviously, what no one cares. So F was what? F was mu into 10m cosine 37 degrees. Right? I'll just make sure. Yes. 10m cosine 37 degrees. Now, obviously, you can rephrase this as sine 53 degrees. Doesn't matter. Sine 53 degrees. Doesn't really matter. Because remember, sine theta is the same thing as cosine 90 minus theta. But we're not going to do that. We're going to go from our previous working, everything from our previous working. Cosine 37 degrees. Okay, and mu was 0.75. Okay, now, Wx is this, so we're going to subtract the two. 10m sine 53 degrees minus 0.75 into, or 10m, خلاص 10m cosine 37 degrees equals to ME. Now, I can factor out M from this. I can factor out M. So I can write M is, now it's M multiplied by 10 sine 53 degrees minus 0.75 into 10 cosine 37 degrees equals to ME. Okay, now M and M will cancel out. This is why I wanted to factor out M. So now do this on your calculator. A is equal to 10 sine 53. By the way, remember the brackets. The brackets can change the answer here. 0.75, open the bracket. 10 cosine 37, close the bracket twice. 1.99, is that the answer? Is it 2? No, 3.5. Oh, I did something with the brackets, didn't I? Give me a second. Okay, so I just realized my mistake. Friction changes. I completely forgot friction changes. So Wy, let me just, Wy is equal to R, right? Wy is equal to N. Now, what is Wy equal to? Wy is equal to 10m sine, or cosine 53 degrees, right? Now I can properly substitute everything because F equals mu n. Mu didn't change. It's the same, the prism, that's what it's called, yes, the prism is made out of the same material. So the coefficient of friction never changes. Mu is the same. But here's the thing, to simplify everything, I'm gonna leave mu as mu. I'm not gonna write 0.75 because you saw the calculation with like the double brackets messes it up. In the end, I will substitute 0.75, but I'm not gonna do that now. So F is equal to mu into 10m cosine 53. Not 35, 53 degrees. Alright, so now what do? We do the same, we do what we did with the right numbers. So Wx is what? 10m sine 53. So 10m sine 53 minus mu into 10m. I'm just gonna substitute mu right away. 10 mu m cosine 53 degrees equals to ma. Same process, factor out m. Now you can factor out 10 too, but you're gonna have to substitute it back anyway. 10 sine 53 minus 10 cosine 53 equals to ma. M and m will cancel out. So a is equal to all of this, which is equal to 10 sine 53 minus 10 cosine 53. What am I doing wrong? Because there's no way this is the right answer. Wait, I forgot the mu. Yeah, never mind. Don't listen to me. Substitute the mu. So 10 mu. This is 10 mu. Okay. Now remember, mu is what? Mu is 0.75. From what? From B. From part B. Right? So 10 sine 53 minus 10 mu. So 10 times 10 times 0.75, 7.5. Remember, because that's 10 times 0.75 cosine 53. So you can straight away just write 10 times 0.75 is 7.5. So 7.5 cosine 53 equals 10 sine 53 minus 7.5 cosine 53, not 4.5, 7.5. 3.47, which will round to 3.5 meters per second squared. This is the answer. Supposedly, let me check. 3.5 meters per second squared, yes. Okay, now, moving on to question 14. The inertial mass of the block in the figure is 12.5 kilograms. The block accelerates at 1.2 meters per second squared on a frictionless table, and when the weight of the hanging load is 15 newtons. Compare the inertial mass and the gravitational mass of the block. Choose the correct answer. Okay, something you need to know. As a shortcut, in every single case, there has been no recorded case. In cases like this, where am I? In every single case, the inertial mass is the exact same as the gravitational mass. It's the same because the gravitational mass, you find it by doing W equals mg. But here's the thing, W will change when g changes, right? But m is a constant factor. M never changes, mass is constant. Inertial mass is the same thing as gravitational mass. Ignore this. This is a trick. It is equal. It's always equal. I'm not gonna talk anymore about it, but it's equal. You don't need to know anything. Okay. Two blocks are connected by a string as shown below, and the upper block is pulled upwards by another string. The masses of the upper and lower blocks are m1 450 grams and m2 150 grams respectively. Use g is at 10 meters per second squared. Alright, so let's focus on m2 first. Now, m2 has this tension and it has the weight, which is, this is 150 grams. You can rewrite this as what? 0.15 kg. Now, G is 10. So what is the weight? The weight is 1.5 newtons, sorry. So what's tension? Tension is equal to 1.5 newtons for the lower one. The lower string, 1.5. Now, how do you get 6? You can treat this whole thing as a system, right? So what's 450 plus 150? 600. 600 grams. Now this is what? This is 0.6 kg. So you have the weight. The weight is how much? 6 newtons. This is how much. This is the tension, right? This tension here between the two becomes an internal force, so it doesn't matter because I'm pulling from here. I won't notice this. So tension is equal to 6 newtons, right? So what is it now? It is 6 newtons and 1.5 newtons. That's your answer. Moving on to question 16. Okay, so let me draw this because this is a figure. This is best explained in a figure. Okay, this is my amazing figure. Doesn't look very clear. Honestly, if you showed me this, I would not tell you what's going on. But it explains the question. So, a 1500 kg car is held in place by a light cable on a frictionless ramp. The cable makes an angle of 25 degrees with the surface of the ramp, and the ramp itself rises 10 degrees above the horizontal. Take g as 10 meters per second squared. Okay, so this is what's going on. I have a car. The car is this block here. It's held in place by a light cable on a frictionless ramp. The cable makes an angle of 25 degrees with the surface of the ramp. So tension, right? The tension will be 25 degrees with this inclined plane. Why is it an inclined plane? Because the ramp itself is 10 degrees above. Okay, now, take g as 10 meters per second. Now, how do you find the tension of the cable? First of all, you split it up into its components. Look, tension is at a 25-degree angle, right? That means that it has components. So, first of all, you would write tension Tx is equal to T cos theta, and Ty is T sine theta. All right? Now, we have the mass of the car. So you can find W. W is equal to mg. But let's find Wx. Wx is what? Mg sine theta on an inclined plane. So it's 1500 times 10, right? G is 10. So 15,000 sine 10 degrees. This is equal to 15,000 sine 10, 2604.7. Alright, now Wy, same process, but you're changing sine to cosine. So Wy is equal to mg cosine theta, which is 15,000, sorry, cosine 10, which is 14,772 newtons. All right. Now, this is just definitions. This has nothing to do with the parts. Well, you'll solve with the parts, but like still, you get what I mean. Now, A is T cos theta. Wait, we have theta here. This is 25 for both of them. Okay, now part A, they want the tension. Tension is very easy to find. Wx, we're gonna isolate along x, because x is the easiest one. So sigma of x is equal to 0. Why? Because it's held in place, no acceleration, so it's in equilibrium. Now, obviously tension, we're gonna take this direction to be positive, because we want to find the positive value of the tension. It's magnitude, but doesn't matter. It's preferred to do it like this. So this is the positive direction. Now, Tx minus Wx, so Tx minus Wx is equal to 0. Doesn't even matter anyway. See, like I'll take one to the other side, they'll both be positive, because it's gonna equal 0. So, how much is Tx equal to? How much was Wx? Wx is 2604.7. Now, Tx was what? Tx was what? This was T cosine 25 degrees, right? So I can say Tx is 2604.7 over its cosine 25 degrees. This gives me 2,874 newtons to the nearest integer, because they told you in the answer, give your answer to the nearest integer. So this is what? 2,874 newtons. So 2,874. All right, part B. The normal reaction of the support acting on the car is blank newtons. So they want the normal reaction. They want N or R, because it doesn't really matter whatever you label it as. So how do you find this? Very simple. You have on your y-axis Ty, R, and Wy, right? Where R and Ty, if you notice here on the free body diagram, R and Ty, or the y component of the tension, are going upwards and Wy is going down. So we're gonna say upwards is positive. And we're also gonna say sigma Fy is equal to what? 0. So tension, the y component of it, plus R minus Wy is equal to 0. What does that mean? You can take Wy to the other side. Ty plus R is equal to Wy. Wy was equal to 14,772. We found it up here. 14,772 newtons. Alright. Ty is what? T sine 25 degrees, as we said. We found T. T was 2,874 sine 25, which equals to 2,874 sine 25, 1214 newtons. So, R is what? 14,772 minus 1,214, which is 14,772 minus answer 13,557.39. But this isn't exactly accurate because I rounded. It's fine. 13,557.4. Hello, I don't know if it could genuinely be 0.5 or 0.6 because of rounding issues, but they did tell you to the nearest integer, so it will be 13,557, 58, doesn't matter. I think they should accept both. They took 13,558. Okay, I rounded. So don't do my rounding errors. So it's 14,772 minus, 1 second, 2,874 sine 25. Okay. Yeah, I don't know how they got 13,558. I got 13,557.4. They rounded something. I'm not sure what. I'm not sure how they got it. But actually, 1 second. Here. We can use the definition of tension up here as this is just T. This is T, not Tx. This 2,604.7 over cosine 25. Let me just check if that changes it. So 2604.7 over cosine 25. Or you can just write tan 25 because you'll have sine here and cosine, whatever. I'm just checking if it works. No, still gives you I don't know. They somehow got 13,558. Whatever. It should be 13,557. Doesn't matter. In the exam, they'll accept both. Okay. Find. I solved this question because I was making the calculation question file. I believe there are no other questions that are like non-calculation after this. So let me just make sure. Yeah, it's this question. So let me just erase everything so I can start explaining from scratch. Okay, so this is the question here. Now, part A wants us to find the tension of AC. They told us a load in equilibrium. So this is very good. That means sigma F equals 0. Using two cables that form an angle of 120 degrees as shown below, the force of gravity acting on the load is 519 newtons. Okay, so first of all, let's draw a free body diagram because I don't have space to do it here. Okay, so this is our surface. I'm just gonna draw it with dashed lines. So you have here, let me just make that line shorter. Then you have here, that's gonna become curved, isn't it? Yes, it will. Okay, now this angle here is 120 degrees. Okay, and you have, this is ACB, I believe. Yes. Okay. So you have a tension here. Let's call it TAC. And you have here TCB. Okay, now they want us to find the tension between A and C, which is TAC. TAC has components, right? So we're gonna draw it like this. We're gonna draw the vector triangle. So this is the x component of TAC. So this is TAC x, and then this here is TAC y. Right? Now, 120 degrees So this means that this angle is what? 60 degrees, right? Because 180 minus 120. Why am I doing this? Because remember, TACY is what gonna be TAC sine 60 degrees. And TACX equals TAC cosine 60. Okay, now to find TAC, we have the gravity, right? I forgot about that completely. We have gravity here, 519 Newton, right? Now, the only force with tension, the only tension that has a y component is TACY, right? Because TCB here, the tension between C and B, there is no x, so there is no y component. It's directly along x. It's directed along x the whole way. So we can write sigma Fy is what? Equal to 0. Now, what does this mean? TACY minus the W, which is the weight, which is what? 519, is equal to 0, which means TACY is equal to 519. Now, this is at the same time, I'm going to move this to the other side because remember, TACY is what? TAC sine 60, right? TAC sine 60, yes. So, times 519. So, TAC, or wait, what? Why did I do that? This is equal to. Okay, so TAC is gonna be 519 over sine 60, which is what? 519 over sine 60. 599.28, 600. They probably, knowing them, they're gonna round to 600. Even though 599 should be the answer, I remember in the question they rounded to 600. Doesn't make sense. It's 599.3. Should have left it at 599.3. Doesn't matter. B, they want us to find TAB, or sorry, what was it? TCB. Right? TCB, yes. Okay, now to find TCB, we can use sigma of x equals 0, right? Because TCB is only directed along x. So you can say TCB minus TACX is equal to 0. So TCB is equal to TACX. Now, how much is TACX? So TAC along x is equal to where is it? TAC cosine 30, right? Or cosine 60. Yeah. So how much was TAC? 600. 600 cosine 60, which is 600 cosine 60, 300 newtons. Now, TCB is the same thing as this, right? They're equal to. So TCB is 300 newtons. And this is your final answer. All right. Next question. So 600, 300. See, do they accept 599? They should. Nope, they accept 600 only. Good to know. They'll accept it in the exam. I wouldn't worry. Okay, this is very, very easy. In the diagram below, the ball hits W with a force. Okay, so as you can see here, right, the direction of the force exerted by the ball on the wall is like this, right? Now, this is the action. What will be the reaction? The reaction will be the wall exerting a right force on the wall. So this here is the reaction, or on the ball. This is the reaction, right? Because it's hitting the ball. Think of it. Like throw something in your room right now. I'll throw my headphone case. I don't know. Will it fall? Yes, probably will. What am I saying? Okay. Yeah, see? It hit the wall. It hit on it to the left. And then, like when observing it from the side, the wall hit it to the right. Hit it back towards the right. That's how it goes back. It recoils and goes back to the ground. So, this is common sense, really. Why am I explaining this? You guys should know this. Question 19. I believe there's only 22 questions, so I think we're done. Okay. This question is interesting. Now, I have it here. A 60 kilogram skier descends from a hill. At the bottom of this hill, the speed of the skier is 10 meters per second. At that moment, the skier continues to move horizontally for 40 seconds before stopping. Take G as 10 meters per second rate. Okay, so he moved like this, right? He moved something like this. This is phase 1 of his motion. And write P1 and P2, but we don't need P1, so I'm not even gonna put them. Right? So this is the skier here. I'm gonna write him as like this stick figure here. Okay, now, no, I just drew him not in a nice way. Anyway, we have him going like this with a certain acceleration, but that's all what matters right now. Acceleration is not a force, remember, so we're only drawing a free body diagram. We have his weight, mg, g takes a stance to 600 newtons, and the normal reaction is also going to be 600 newtons. Doesn't matter. Okay, we have friction, and that's about it. We don't have any other forces acting on the guy because there's no force pushing him like this. Now, okay, so he's moving, right? He's still moving on the bottom of his hill. He is moving, but he's slowing down. So what does that mean? Sigma f x. We're concerned about friction, right? Sigma of x is what? ma. Now we don't have a. What do? We're gonna use our equations of motion, of uniform rectilinear motion, or uniformly accelerated. What is it, UARM? Now, I like to use a shortcut called SUVAT to tell me what I have given. So do I have S? Do I have the S as displacement? No, I don't have S. Why? Do I not have S? Wait. No, I don't have S. Why am I asking that? I don't have S. I don't have U. Or yeah, I do have U. I'll use 0. No, U is 10 actually. I have U. 10 meters. Because look, it says at the start, the bottom of the hill, his speed is 10 meters per second. Use initial velocity. V is what I want. V is 0, right? Because he's slowing down at the end of his motion. He slowed down. What? He slowed down? He slowed down. 0 meters per second. A is what I want to find. And T is 40 seconds. Right? Yes. So, what equations do I have that combine V, U, A, and T? V equals U plus AT. Right? So, V is 0. U is initial velocity, or V0. 10 plus 40A. So, 40A equals negative 10. A is equal to negative 0.25 meters per second squared. Right? This is my answer. Now, this is not my answer to the question. This is just an answer for my acceleration that I'll use. Now I can go back and write sigma of x is equal to ma. I only have friction acting, right? So I have F equals ma. That's the only force I have on it. I only have friction on this guy. I don't have any other force pushing him forward. So M is 60. So F is equal to 60 into negative 0.25. Which is 60 over 4. 15, right? Is it not 15? It is 15. Negative 15 newtons. So here's the thing. Negative 15 just shows the direction that it's going backwards. That shows that the friction is backwards. That's it. That's all it's showing me. Yeah, because I took, technically speaking, I took this direction to be positive, right? But when considering acceleration is negative, I took this direction to be positive, but that's not what's happening here. Or actually, technically speaking, I took this direction as positive. I don't know. I took a direction as positive and it's the other way around. The point is you use the magnitude, which is 15 newtons. That's your answer. Now, the coefficient of friction along the horizontal stretch given to 3 decimal places. I'm going to draw it here. So, F equals mu R. R is 600 newtons. F is 15. 15 is equal to mu, which is what we want to find, times 600. So mu is equal to 15 over 600, which is 0.025. Okay, let me just make sure. 15, 0.025. Okay. Here's the thing. The calculations, what I said, I took this direction is positive or this direction is positive. I don't know. It doesn't matter to me. That's what I meant by I don't know. Because here's the thing. I only have one force, right? So even if I get a negative answer, I'm gonna assume it to be positive. Why? Because this direction is obviously gonna be the direction that the force is acting on is obviously gonna be the positive one. I don't have a negative direction because I only have one force, and I'm assuming that to be the positive direction. So when I get negative, I don't really matter. It doesn't really matter to me. I'm just gonna take the magnitude of it. Just like, as a simple fix, like a mental note. Okay. When a thread thrown over a fixed pulley, two loads of 0.75 kg and 0.85 kg are suspended. Within 2 seconds after the start of the movement, each load travels a distance of 1.2 meters. Based on the experimental data provided, the acceleration of gravity is what? Okay, let me draw this now because there is a drawing here. And let me copy and paste the question to the notes. I do have it copy and paste. Let me just draw the diagram. Okay, so this is my drawing. All right. It's a good drawing as far as I'm concerned. If anyone has any complaints, please take it up with me. Now what do we do? We're gonna use 2 watt because we need acceleration. Sigma of y is equal to me because they're moving. It says they moved. They traveled the distance, so they're moving. So they have an acceleration because they started at rest. They were suspended at the start. Within 2 seconds after the start of the movement. So obviously start 0 to something to a speed. And that caused the distance, which means there's an acceleration. Now, sigma of y is equal to me, right? So we need to find a. A is going to be constant throughout this pulley. So if I find one a, it's fine. The other is basically there. So how do I find it? Let me use it. 2 watt. S is my displacement. I have at 1.2 meters. U, I have technically 0 meters per second, although it's not given, but you can imply it. V, I don't have. A is what I want to find. And I have T. I have T as what? 2 seconds, right? 2 seconds. So what equation do I have that gives me delta x, or the displacement? U or V0, T and A. The long one, delta x equals half AT squared plus V0T or UT. I'm not going to take x0 because I took it to the other side by making it delta x. Now, here's the thing. It starts off at rest, right? When it starts off at rest, how do I know? Because it's u 0 meters per second. So what do? I remove this part. Done. This is my equation when it starts from rest. So S or delta x is 1.2 meters equals to half A, which is what we want to find, T squared. T is what? 4. T is what? 2. 2 squared is 4. Half 4 times 2. 4 times half is 2. 2a. So what am I gonna do? A is equal to 1.2 over 2, which is 0.6 meters per second squared. This is my acceleration. Nice acceleration. It's easy to work with. So now I need to know the direction of motion. Is it going this direction down? So that means this block is going up. Or like what I mean is this block will go downwards and this block will go upwards. Or is it the other way around? This block is going downwards and this block is going upwards. Which block's heavier? This one, right? 0.85 kilograms. Which means, right, that this block's the one that's going to go downwards because this one has a bigger weight. And weight is the only factor that's making the blocks go down. Right? There is no other force that drives it downwards. So what does that mean to me? To me as a person, this helps me figure out which direction, like which one is moving down. It's gonna be this one. So this one, the weight of it is bigger than the tension. This is what I wrote here, 0.85 G. G, we don't know G. They didn't give us G. I just used it because I knew it would cancel out eventually. I can use G as 10 and find an approximate value, but I'm hoping it cancels out. No, wait. I can't cancel it out because they want us to find G. Never mind. 1 second. That doesn't work like that. So, 0.85 G minus T. I'm working with the block that's going down. Is equal to MA. M was what? 0.85. Let me just check. 0.85. A is 0.6. So 0.85 times 0.6. 0.51. So tension is what, take this to the other side, and this one to the other side, 0.85 G minus 0.51. This is my first equation. I'm going to use simultaneous equations. So for the second one, the second block, this block goes up, right? So tension is greater than the weight. So T minus, or you can say tension is the positive direction. T minus 0.75 G, because you don't know if it's greater than the weight necessarily. It doesn't have to be. All you know is tension is in the positive direction, so you take it this way. T minus 0.75 G is equal to 0.75 times 0.6. 0.75 times 0.6 is 0.45. So substitute this. So 0.85 G minus 0.51 minus 0.75 G equals 0.45. Take everything to the other side and rearrange whatever. So you'll get 0.1 G equals 0.85 G minus 0.75 G is 0.1 G. 0.45 plus 0.51, 0.96. So divide by 0.1, G is 9.6 meters per second squared, which I have to say is a pretty close approximation to the actual value. So this is your answer, 9.6 meters per second squared. Let's just check. 9.6, yes, that's the answer. Question 21, which is the second last question. I don't remember if it's calculation. It is calculation, of course it is. Let me copy over everything. I have the question, but let me just copy over everything I need to copy over. Okay, so this is the question. Really easy question. The diagram below shows two forces, F1 and F2, of magnitudes 40 and 30 newtons, respectively. Drag and drop the correct answers to complete the sentences below. The magnitude of the resultant force is blank newtons, and the angle it makes with the positive x direction is something degrees. Okay, so let's split up the force. F1 is directly along x. I don't need anything else to do with it. There is no components for F1. F1 is fully along x. Let me just change this back to 3. F1 is fully along x. I don't need to know anything about it. F1 is 40 newtons along x. That's all I care about. F2, however, has components, right? So I'm going to split it up. F2y and F2x. Okay, now, what do I do here? Let's find F2y and F2x. So F2y is what? F2 sine theta. Theta in our case is 45 degrees. It's given to me here. So F2 is what? 30 newtons. So 30 sine 45 degrees, which is what? 15 radical 2. I don't need to know 15 radical 2. Because sine 45 degrees is radical 2 over 2, right? Wait, sine 45 radical 2 over 2. Same thing with cosine. So this is newtons. Now, F2x is 30 cosine 45 degrees, which is what? 15 radical 2 newtons. If you want, you can check it on the calculator, but I already know. F1x, there is no F1y, so I'm just going to write it as 0, is 40 newtons. F1y is 0 newtons. Now, here I can resolve my forces. So they want the resultant. So we need F net is what? Radical F net x squared plus F net y squared. See, it's much simpler to write sigma. Sigma fx, sigma fy. But both work. This should be actually fx net, fy net, but it's fine. So now sigma fx, which means fx net. Where is it? Sigma fx is just gonna be what? You can see they're both in the same direction, 40 and f2x. So 40 plus 15 radical 2. Okay, and sigma fy is just 15 radical 2. Right? Because, you know, just resolving them. Using these values we have. Okay. So, F net is equal to 40 plus 15 radical 2 squared plus 15 radical 2 squared. This gives me radical 40 plus 15 radical 2 squared plus 15 radical 2 squared. 64.8 newtons, which is an option, thank God. So, and the angle it makes with the positive x direction. So for this one, part B, angle alpha is gonna be the inverse tangent, arctan, of sigma fy over sigma fx. All right. So this is gonna be arctan. Arctan is tan inverse. They're the exact same thing. It's just your preferred method of writing it. 15 radical 2 over 40 plus 15 radical 2. So this is gonna be tan inverse of 15 radical 2 over 40 plus 15 radical 2. 19.1. 19.1 is an answer. Okay, 19.1 degrees. And this is our answer. Let's just check. It's 64.8 and 19.1. 64.8, 19.1. Okay, so this is the last question now. It's out of 22 questions. This is my last question. It's very, very easy, but the question is just long. The diagram shows a particle A of mass 6 kg resting on a smooth plane which is inclined at 30 degrees to the horizontal. A light inextensible string connects A to a second particle B of mass 4 kg chunks freely. The string passes over a small pulley P fixed at the top of the inclined plane, and the portion AP of the string is parallel to a line of greatest slope of the plane. The system is released from rest with the string taut and the hanging part vertical. Okay, for this one, while I could work with G as just G since they didn't give me G, I'm just going to say that G is equal to 10 meters per second squared. And I'm going to round my answer to whatever they give me. I'm honestly not in the mood to work with G since it's the last question, which is 11 p.m. almost. I'm tired. So, this is A. A has 6 kg mass, right? So, what's the weight? The weight is 60 kilogram, 60 Newton. But let's split it up into X and Y, like in one go. So on Y, it is 60 cosine 30 degrees. And here, it's a very long line. Here it's 60 sine 30 degrees. Right, and then you have the Norman. And then you have the tension. Right, and then for B, the weight is what? 4, so 40 newtons. And here, the mass is 4, sorry. The tension. Now, what's the tension? So to find tension, you're going to work with this case. But again, how do I know which direction this is moving in? So, here, which is bigger? Which block is heavier? Mass A, which is 6 kg, or mass B, 4 kg? Mass A, right? So we're gonna go in this direction because mass A is the heavy one. It's gonna win. 60 sine 30. Anyway, 60 sine 30 is 60 sine 30 is 30, right? 60 sine 30 should be 30. Yeah. So this is 30. I'm just gonna erase this and put 30. Oh wait, but that changes it now, though. Does, yeah, no, okay, no, that changes it. See, this is why you should calculate it mathematically. This is gonna go down like this direction. This is 30 newtons. So 40 minus tension, okay, I'm working with this block right now to find tension, is equal to MA. The acceleration is what we don't know. Mass is 4A. So tension is equal to 40 minus 4A. Right? Now, this is the first equation. This is equation 1. Now we're going to work with this one. 60 cosine 30. Let me find it in one go too. 60 cosine 30. 30 radical 3. Okay. So, sigma fx for this one is also MA. So, tension, no. How much? Yeah. Tension minus 30 is equal to MA. Because remember, it's going this way. So this block will go this way. T minus 30 is equal to 3A. Right? Because the block is, no, 6A, sorry, 6A. The mass is 6. Tension we found at 40 minus 4a minus 30 is equal to 6a. We're just gonna work really quickly. Take 4a to the other side, and 40 minus 30 is 10. 10 equals 10a. Acceleration is 1 meter per second squared. This is the answer to part A. Part B, the tension in the string just substituted. T is equal to what? 40 minus 4a. So 40 minus 4 is equal to 36 newtons. That's the answer to part B. All right, that's the end of the quiz. Good luck, guys. Hope you had a good break, and hope you have a good term too.